Data science. Data science is a branch of mathematics and statistics to obtain useful and meaningful insights about the dataset and trends from the raw data or information. Using programming, business, and analytical skills, you can process and manage the dataset. The field of data science goes back to its root in statistics. Having said that, this field is a combination of programming, business acumen, and statistics. It is essential to learn more about each topic to have an idea of how you approach the learning process. Data science is a mix of numerous algorithms, tools, principles, and languages to identify the hidden patterns within the variables in the dataset. By using data science, it becomes easier to predict the outcomes. A data analyst uses the data only to explain what is happening in the present using a historical dataset. On the other hand, a data scientist only looks at the data to obtain insights from the dataset. He also uses some advanced algorithms to identify the probability of the occurrence of an event. He looks at the data from various angles and aspects. Data science is used to make informed decisions based on predictions made using the existing dataset. It is centered on building, cleaning, and organizing datasets. On the other hand, data analytics pertains to analyzing data to answer questions, extract insights, and identify trends. This is accomplished using different tools, techniques, and frameworks that vary depending on the type of analysis being conducted.
Today we're going to study about the analytics. It is the systematic investigation of data or statistics in which it is used to discover, interpret, and communicate meaningful patterns in a data.
Predictive analysis has its roots in the ability to predict what might happen. These analytics are about understanding the future. Predictive analysis provides companies with actionable insight based on data. Predictive analytics provides estimates about the likelihood of a future outcome. If you want to develop a model to predict the possibilities or outcomes of futuristic events, you need to use predictive casual analytics. Predictive analytics is the best suit for use cases where trends can be identified and modeled based on historical data. The technique is less effective in situations where there are too many variables at play or when relationship between variables are not well understood. In these cases, casual analytics may provide a better understanding on how different factors influence each other.
This form of analytics is more about providing the right information to make an informed decision. You can also use this type of analytics to predict a range of associated outcomes and prescribe actions. An example of this type of analytics is a self-driving car. You can run numerous algorithms, which is a procedure or formula for solving a problem based on conducting a sequence of specified actions on the data collected from the cars and use the results to make the car more intelligent. This makes it easier for the car to make the right decisions to turn, slow down, speed up, or identify the direction to take. So when we say machine learning, it is a group of computational data that performs pattern recognition, classification, and prediction by learning from existing data. It is also a branch of artificial intelligence which focuses on data and algorithms.
Make predictions. Numerous machine learning algorithms allow you to make predictions using unstructured, semi-structured, and structured datasets. Let us assume you work for a finance company and you have a transactional data available. You need to develop a model to determine the future trend of transaction. To perform this analysis, you need to supervise machine learning algorithms such algorithms are used to train the machine with an existing dataset. You can also You can also supervise machine learning algorithms to develop a trained model to detect future frauds based on historical information. Machine learning algorithms have also numerous benefits, including data mining capabilities, automation, personalization, fraud detection, decision support, and adaptability. Their importance continues to grow as businesses industry recognize the value of harnessing the power of data to gain insight and drive innovation. Machine learning algorithms can also applied in accounting to automate tasks, improve accuracy, detect anomalies, provide insights, and enhance decision-making processes. They have a potential to transform traditional accounting practices and enable accountants to focus value on tasks such as data analysis, strategic management.
Pattern discovery. Not every data set has variable you can use to make the necessity prediction. This is not true. There's a hidden pattern in every data set, and you need to find those patterns to make the required prediction. To do this, you need to use an unsupervised model since you do not have any predefined label in the data set. One of the most common algorithms used to identify pattern is clustering. Let us assume you work for a phone company and you are tasked with identifying where to set up cell towers in the area to establish a network. You can then use the clustering algorithm to identify where you can set up the towers to ensure every user in the area receive the optimum signal strength.
In the past, organizations managed small volumes of data. It was easy to analyze and understand the data and relationships between the dataset using some business intelligence tools. Most traditional business intelligence tools only work on structured datasets, but most of the data collected today are semi-structured or unstructured. It is important to understand that most data collected now are semi-structured or unstructured. Simple business intelligence tools cannot process this type of data, especially since large volumes of data are collected from different instruments. For this reason, we need to develop advanced and complex analytical algorithms and tools to process, analyze, and draw some insights from the data. It is not only for this reason why data science has gained popularity. Let us look at how data science is used in different domains. First is customer service. How great would it be if you could know exactly what your customer wants? Do you think you can use existing data to learn more about your customers, such as purchase history, browsing history, income, and age? You may have had this data with you in the past as well, since you use different mathematical and statistical models. You can effectively work with large volume of data and identify the right products to recommend to your customers. This is a great way to bring more business to your firm. In today's competitive business landscape, customer satisfaction is a critical factor that can make or break a company's success. It is no longer enough to offer a product or service that meets customers' needs. Companies must go above and beyond to deliver exceptional customer experience that leave a lasting impression. Data science can also play a crucial role in improving customer service by analyzing customer feedback and sentiment data. Companies can identify areas where they need to improve and take action to address these issues. This could involve anything from improving response time to providing more personalized support. Second, let us now consider how you can use data science in predictive analytics. Data science may also detect patterns in seemingly unstructured or unconnected data, allowing conclusions and predictions to be made. Consider weather forecasting. The algorithms used take data from aircraft, satellites, radars, ships, and other parts to collect and analyze data. This helps you build required models. You can use these models to predict the occurrence of any natural calamities. Using this information, you can take the necessary measures to save lives.
Self-driven cars. How would you feel if your car could drive you home? Numerous companies are trying to develop and improve the workings of a self-driven car. The cars collect live information from various sensors, such as lasers, radar, and cameras, to create a map of the surrounding environment. The algorithm in the car uses this data to decide to speed up, slow down, park, stop, overtake, etc. These algorithms are often machine learning algorithms. The innovation in the automotive industry is no longer driven by manufacturing, but by data science. Data science has also made inroad into the transportation industry, such as with driverless cars. It is simple to lower the number of accidents with the use of driverless cars. For example, with driverless cars, training data science is applied to the algorithm and the data is examined using data science approaches, such as the speed limits on the highway, busy streets, and more. Data science are the pioneers behind perfecting the brain of the driverless cars. Given the perception and the localization, cars can now predict the behavior of every object, vehicle, or human in their surrounding. They can anticipate how the object moves, in which direction, at which speed, what trajectory they will follow. Obviously, not all of the data that each vehicle transmits will be important. In fact, there are a multitude of distraction and background noises that a human driver tunes out in order to focus on the important aspect of driving. Data science are needed to analyze input and decide what is important and what isn't. With artificial intelligence and data science working in concert, the possible are nearly limitless. The combination of human common sense and computerized complexity that lies at the core of autonomous vehicle technology is astounding. What makes it so amazing isn't just the thought of futuristic cars that can chauffeur us around, but that programs are being created that can teach computers to learn. While cars may never be capable of human intuition, with the right data, the right algorithm, and the right data scientists fueling the process, they may eventually be able to make our roads a safer and more efficient way to travel.
Data scientist. A data scientist uses data to answer some business questions and concerns. The term data scientist was coined when people learned that a data scientist uses data, various mathematical or statistical functions, operations, and other scientific fields and applications to make sense of the data in the database. Data scientists crack various data problems using their expertise in specific scientific disciplines. He works with different mathematical, statistical, and computer scientific elements. He does not necessarily have to be an expert in these fields. He would use some technologies and solutions to develop the right solutions and reach conclusions crucial for the organization's development and growth. A data scientist finds a way to present the data in a useful form compared to the data available in the dataset. They work with both structured and unstructured data.
Good day everyone. I am Matthew Panican and I will be discussing the difference between data science and business intelligence. Before we proceed to our topic, let's first discuss the meaning of business intelligence. Now, what is the meaning of business intelligence? It means that of performing descriptive analysis of data using technology and the skills to make informed business decisions. The set of tools used for business intelligence collects, governs, and transforms data. It facilitates decision making by enabling the sharing of data between internal and external stakeholders. Now, the difference between data science and business intelligence is that data science pertains to predictive and prescriptive analysis, whereas business intelligence focuses on descriptive analysis. The scope, data, integration, and skill set are other distinctions. The type of analysis in data science, it examines the likelihood of upcoming circumstances and events in order to predict company trends, consumers' behavior, and product success. Predictive analysis examines historical data. It attempts to provide answers to predictions about the future. Prescriptive analysis looks for a particular business issue, while business intelligence examines the past. It makes historical data easy to perceive and comprehend for business units by using descriptive analysis to deliver it to them. The present state of the firm is frequently communicated in reports that are produced using business intelligence. For the scope, the data science begins with an idea in particular or hypothesis because its goal is to forecast occurrences or conditions. The next step is to test the validity of the hypothesis. After all, it is something that is scientific. This particular hypothesis is the subject of predictive analysis. On the other hand, business intelligence need a broad breadth. Whatever business unit must be able to produce or whatever kind of report they require using the descriptive analysis, the information must, for instance, be used to assist a product manager's assessment of the success of his most recent venture or a sales director's analysis of her quarterly results. For the data integration, business intelligence benefits from the extract, transform, and load, or we can say ETL data integration process. Prior to importing the data into the data warehouse, it converts the data. Because the data warehouse schema is established, business users can easily build reports using analytical tools. The alternative is extract, load, and transform, or ELT, which involves loading data into the data warehouse before transformation. When a query is made, data can be modified using this data integration technique. ELT is a good choice for data science applications since the query can be modified to fit the needs of the particular investigation without being restricted to a particular schema. Now, for the skill set, a data scientist obviously work in the field of data science. Be that as it may, information science isn't finished in a vacuum. Data scientists still require assistance from IT, operations, business units, finance, and other departments. In addition to possessing a comprehensive set of skills. For business experts who are related with business insight, they positively have the essential range for abilities. Business users, on the other hand, stand to gain the most requirement business intelligence. Consequently, the majority of business intelligence tools have efficient self-service features. Without this component, business bits of knowledge wouldn't be promptly accessible to business clients. And that's all. Thank you for today.
Life cycle. The following are the life cycle phases of data science. In the initial phase of the project, referred to as the discovery phase, it is crucial to comprehend the business requirements, specifications, budget constraints, and priorities. Aspiring data scientists should possess the ability to ask pertinent questions and evaluate the availability of necessary resources, personnel, technology, data, and time to support the project. This phase involves framing the problem statement and formulating an initial hypothesis to be tested. The subsequent phase, known as the data preparation, focuses on identifying and acquiring the required resources for data analysis. It entails developing or identifying an analytical sandbox environment where data can be processed, explored, and prepared for modeling. Operations such as data extraction, transformation, loading, and additional transformations are performed to facilitate data movement into the sandbox environment. Programming languages are often employed to cleanse, transform, and visualize the data, enabling the identification of outliers and potential relationships between variables.
Phase 3, plan the model. The approach and method you will need to use to draw a relationship between the various variables in the dataset must be identified during this phase. The algorithms you can apply in the following stage of the life cycle will be guided by this relationship. Applying multiple formulas and visualization techniques, you must use exploratory data, analytics approaches, and tools to achieve this. Here are some tools that are used for this. R. This programming language has various modeling capabilities. It is also a good platform to use and develop the right models if you are a beginner. SQL. This provides a set of methods to perform analysis within the database using different predictive models and mining functions. Access or SAS. These tools can be used to access data from various storage platforms like Hadoop and use that data to create a reusable and repeatable model. Although there are several programs on the market for developing model strategies, R is commonly used. You will be given the necessary information and insights at the conclusion of this phase to help you choose the algorithm to use. The development of the model and application of the algorithm comes next. Phase 4. Build the model. You must divide the dataset into training and testing data cells after choosing the algorithm to use. You must think about the current tools and resources at this step. Check to see if they are suitable for the build of the model. Make sure to choose a stable environment in which to run the models. For developing the model, you must study many methods such as clustering, connection, and classification.
In phase 5, operating the model. In this phase, you run the data through the model and deliver the reports and necessary technical documents. This means is collecting all the data that you gather and giving them insights. Additionally, you may also need to run the model in the production environment to test if it works the way it needs. And this will be watching the model to operate in the way that you want it to. This gives you an idea of how the model performs on the real-time data. And in this phase, you can also determine any constraint in the model. Next is phase 6, communicating the results. This is the most important phase. It is to evaluate if the model given you the needed results that you gather. This is you will see the final results regarding the information you all gather. You can do this by analyzing your hypothesis. This is the last phase of the data science, and this is where the identity and key findings and communicate the same to the information. You can also determine the results of the model based on the criteria you identified in the first place. That's all. Thank you.